So in this video I'll show you the method 2, which is the proper way of actually solving the transformation challenge by inspecting the code given here. So this is obviously a Python code, and you need to download the file to retrieve the Chinese characters here, or Japanese characters. Okay, so I've already copied the code here, and let's quickly analyze it. So this assumes that you have a flag with, of course, picoCTF flag here, and the loop will use the string with 2 steps and the starting index of 0. Then we will work with the flag here. So for every 2 steps, I do this. Okay, so flag I, which is the first character in the 2 step here. So what it actually does is, for each iteration, it will work on flag I and flag I plus 1, which in this case, in this example, H and E will be what is involved in the first step, and then L and L will be on the second step, and so on. Alright, so the first character in the loop will be shifted left 8 times, and the second string character will be left doing nothing, and then they will be converted into their Unicode value. Then both their Unicode value added up will be converted to their character form. That's why you get like weird Chinese letters, because the logical shift left here turns the Unicode to an extremely large value that it exceeded our normal 1 to 8 range, right? Which is our English characters. So for those that forgotten or don't know logical shift left, basically I'll use binary for a better representation. So let's say you have a binary 1010. If someone tells you that you're shifting 3 times, right, it actually means your original binary is being shifted left 3 times literally, and the new void spaces will be filled up by 3 zeros because you shift to the left 3 times, right? Yep, so that's it. But in this case, it is shifted 8 times. So for example, if I were to have a binary that is, of course, 8 characters long, I have 8 bits right here, which is common in 1 to 8 ASCII. If I were to shift 8, then everything will be moved 8 times to the left, leaving me 4 new zeros, right? This would be the idea of the first part of the code. Okay, so the second part here basically uses back the original binary. So for example, maybe the second binary is 1111110101. All right, so it will do nothing and then add it with the first part of the OR. So in this case, this will be added with this. So obviously, without changing the original character's binary, I am able to successfully add the second character's binary value to the first one. So it will look something like this, right? It will be this. So this binary value is then converted into the character form, which ends up lead to these Chinese Japanese characters. So I use binary to obviously show you the literal sense of how it works, but in OR here, definitely it is using the decimal Unicode. For example, like 127106 for like letters representing them. Okay, so that's the idea. So we know that in order to get back the characters here, it is definitely possible, because in each binary, in each Chinese or Japanese characters, one represents 2 English alphabets, and each alphabet is represented by 8 binaries, 8 bits right here. So this will be the first English character. This second part will be the second English letter. Okay, so based on this knowledge, I have created a script here, which does basically this. Okay, wait, this is commented out, but yeah, I'll explain the first part first before I run the whole thing. So this thing is the original text, and then I have a simple loop. So in this case, I'm using hex. So I'm converting this decimal into decimal Unicode to hex instead of like binary, because let me run it for you. So if I were to change to binary, right, it is possible, but it is not as readable as, for example, like using hex. Right, hex is more short and it is more clearer of what I'm working with. So in this case, 8 binary or 8 bits equals to 2 hexadecimals, right? So 2 hexadecimals equals to 1 English letter in this case. So what I'm doing here, my idea is to basically break down the string of hexadecimals into group of 2. So every group of 2 will be converted back to their original English letter. So that is the idea of the commented section here. Okay, so x is 0, x is y is 1. This will be like the control indexes, sorry, not index, but like the control variables, which will help me to identify the first character and the second character for each group. So as you can see here, I iterate through the string which I have gotten just now. Wait, where's the thing? Okay, the terminal. Let me run it one more time. Okay. So this thing. So this string will be passed into this loop. Yeah. And if k mod 2 I get 0, then I will run this part of the code, because I also want to make sure that we are doing the 2 steps method, so I won't overlap, right, for the characters. So every two loop I will do this. So this, what actually is this? So we're taking the first letter, which is x, and the second character, which is by using y here, to basically convert them into integer values, then turn them back into their original character. So that is what it actually does. Then it is appended into the real string right here. Then it will keep on going and produce my real flag. Okay, so I hope this makes sense. So let me run it one more time to get our actual CTF flag. But wait, I think that's it. That's it for the solution. So let me pass it into Pico to verify. Yes, so I solved it.